Hello everyone, my name is Gyan Shah. I am from VIT Chennai campus. Today's my presentation topic is ignition system. So, first of all, what is the ignition system? The ignition system is a system for igniting a fuel-air mixture. Ignition system as well as known in the field of internal combustion engine, such as those used in a petrol engine used to power the majority of motor vehicle. So basically ignition system is used in the petrol engine. Now the functions of the ignition system provide a method of turning a spark ignition engine on and off, operates on various supply voltages, produce high voltage arc at the spark plug electrode, distribute spark to each plug in current sequence, time the spark so that it occurs as the piston near the DTC on the compression stroke. Varies the ignition time as engine speed, load and other conditions. So this is the basic functionalities of ignition system. The main functionality is a continuous where it is operate on the various voltages. Okay. Now what is the requirement of the ignition system? Why we require this ignition system in our engine? So to make a spark inside the engine cylinder which is strong enough to ignite the air fuel mixture in normal atmospheric condition, only about the 600 volt are needed to make a spark. However, in the pressured environment of the engine cylinder, 8000 to 30,000 volt will be required. To ensure the spark happens at the right time for the each cylinder going through the 4-stroke cycle. For an example, just at the end of the compression stroke, the ignition system also has to change the time at which the spark occurs. The ignition timing depends on engine operating condition. For an example, how fast the engine is turning. So basically it is required to ignite the spark inside the cylinder to the air fuel mixture, so the starting will be occurs. Now the factor consider for design the ignition system. First is the combustion chamber design. Second is the air fuel ratio. Third is engine speed range. Fourth is engine load. Fifth is engine combustion temperature. And the sixth is emission regulation. So the combustion chamber design is very important. If it is very big, then it's create the problem. Air fuel ratio is also required. Required in particular range if there is a lean mixture or is the more fuel air ratio is there. Okay. In engine speed range is also important for the ignition system. And the engine load, the load is calculated by using the at the sensor or located at the transmission line. So by using that we can measure the engine load. So this factor is also very important in the ignition system. Now the type of the ignition system. There is a mechanical ignition system, electronic ignition system, distributed-less ignition system. In this lecture, we can understand the mechanical ignition system as well as some topics related to the electronic ignition system. The objectives: explain how the ignition coil create the 4000 volt. Discuss the crankshaft position sensor and the pickup coil operation. This is very important. Describe the operation of a waste spark and the coil on a plug ignition system. These all topics we are discussed in this presentation in the next PPTs. Now the ignition system operation. The ignition systems include components and wiring necessary to create the distribute a high voltage up to 40,000 volt or more. ignition system supply voltage close to battery voltage to the positive side of the ignition coil and pulse the negative side to the ground. This is very important. The battery connection is must be in the all the connections are required in the positive side, and the remaining the negative side will be the for the pulses are required. So these are the main important things when we are connecting the battery to our ignition system. Next is the ignition coil. So in this, the heater of any the it is the heart of the any ignition system is the ignition coil. The coil create a high voltage spark by the electromagnetic induction. Many ignition coils contain two separate but electrical connected winding of a copper wire. This figure shows the internal construction of the oil-cooled engine coil. Notice that the primary winding is electrically connected to the secondary winding. The polarity of the coil is determined by the dielectric in which the coil is wounded. So as you see in the figure, there is a two wounding springs are there. First of all, it's a primary winding, and second is the secondary winding. In the primary winding is connected with the negative terminal and also in the connected with the positive terminal. Now the main current is flowing in the primary winding due to and the high tension current is produced in the secondary winding. These all things we are discussing the next PPTs. Now the ignition coil. Ignition coil is self-inductions, mutual inductions, how ignition coil create 40,000 volt primary ignition circuit and the secondary ignition circuit. These are the ignition coils related information. Now this ignition coils, this figure shows the primary and the secondary electronic ignition using the ballast resistor and the distributor to produce the ignition coil from the overheating at lower engine speed. Many electronic ignitions do not use the ballast resistor but use the electronic circuit with the module. Now ignition switched and the triggering. For any ignition system to function, the primary current must be turned on the charge the coil and off the allow the coil to discharge, creating a high voltage spark. This turning on and off of the primary circuit is called the switching. The unit that does the switching is an electronic switch, such as a power transistor. This power transistor can be located in any of the following locations: in the ignition control module or in the PCM in the computer. Now the primary circuit operation. There is a two circuit, primary circuit and the secondary circuit. First of all, we see the primary circuit operations. To get a spark out of the ignition coil, the primary coil circuit must be turned on and off. This primary circuit current is controlled by the transistor inside the ignition module, or that in turn is controlled by one of the several devices including pickup coil, Hall effect switch, magnetic crankshaft position sensor and the optical sensor. Now as you see in the figure, the primary circuit operation is shows the rotary ferrite metal regulator is there, the narrow gap resistance in the strong metallic magnetic field for the coil, and the permanent magnet is located. The voltage reverse as a star wheel moves past closest to the point. So this is when we pass to the closest point, the voltage reverse. The same thing is shown in the second figure. The wide gap offers weak magnetic field for the coil, and also the permanent magnet is located there. Now the operation of the typical pulse generator. At the bottom is the line drawing of the typical scope pattern of the output voltage of a peak coil. The module received this voltage from the pickup coil and opens the ground circuit to the ignition coil when the voltage starts down from its peak. Now the same thing is shown here in the different way. The varying the voltage signal from the pickup coil trigger the ignition module, which is shown with earlier in the slide. The ignition module ground and unground the primary winding of the ignition, create a high voltage spark. So in this way the high voltage spark will be the generated in. Now the Hall effect switches use the metallic shutter to shunt magnetic line of force away a silicon chip and related circuit. All Hall effect switches produce a square wave output for every occurring triggering. So as you see in the figure, the Hall effect unit is shown there and the permanent magnet is showing there. Now this Hall effect unit and the permanent magnet is both are the perpendicular to each other, as well as the arrow indicate the normal magnetic lines of the force, but that is also the perpendicular to each other. So these three things are perpendicular to each other. Now in this we can put a signal Hall effect unit. We can see in the earlier unit. Now as you can see that this is the distributed ignitions working. Now when the key is on, then the battery is supply is a current to these winding coils. Now this is the current is passing into the primary winding coils. Now the this distributor unit, we are showing that there is the uh, conductance is there, and the capacitance the capacitance is all inductors and the capacitors are located there, and this is the matching when the current is passing to this camshaft. Now this camshaft is directly connected to the crankshaft. Now when the matches will be occur, at that time the current will be flow in this. When it is discharge the matching, at that time it is a back current flow in the circuit. In this way the capacitor is also the charge in that time. After the connection of these brushes, this capacitor will be the discharge, and due to the secondary winding will be the charge. Secondary winding will be charged, and the primary winding stop their charging. Now this is secondary winding will be charged. This convert the 12-volt battery to the required voltage, which is the 2000 voltage. Now this volt is direct goes to the distributor unit. Now in this distributor unit, the distributor point are there. The 4 spark plug is there, therefore is the 4 distributor point we are connected that, and the rotor is rotating in this distributor. Now when the rotor is reached to this distributor point, this current flows is a jump to this distributor point and goes to the spark via the high tension cable. Now in this spark the central electrode and the primary electrode having the bigger gap between that. So this current is directly passed between these two gaps, and there is a 0.6 mm gap at the end of the spark, which at that time this current will be converted into the gas, and then after is generated the heat, and finally the spark will be generated. Now this spark plug is covered with this insulator part. So in this way the distribution ignition working is going on. Now we can see the NOx sensor. Now in this NOx sensor we can see that the NOx sensor are used to detect the abnormal combustion, often called a ping, spark, knock, or detonation. Whenever the abnormal combustion occurs, a rapid pressure increase occurs in the cylinder, create a vibration in the engine block. The diagnosing the NOx sensor and the replacing the NOx sensor is required for that. Now in this NOx sensor you can see that in the figure the typical waveform from the NOx sensor during a spark knock event. This signal is sent to the computer, which in turn retain the ignition timing. This timing rated is accomplishment by the output command from the computer to either a spark advanced control unit or directly to the ignition module. Now we can see the spark plug. As we saw in the earlier, the spark plug are manufactured from the ceramic insulator inside the metal seal. The thread of the shell are rolled and the seat is formed to create a casting seal with the cylinder head. Now this ceramic insulator is there, metal shell is there, thread, side electrode, central electrode, insulation is also there and the metal shell is also there. By these parameters we can make the spark plug. The physical difference in the spark plug includes the reach. This is the length of the thread part of the plug. Heat range, type of seat. The resistor spark plugs, platinum spark plugs and the iridium spark plugs. These are the types of the spark plugs. Now in this next we can see the spark plug, the fast heat transfer, medium heat transfer and the slow heat transfer hot plug is there. Now electronic ignition system. First we will discuss the electronic ignition system. Now the advantages of electronic ignition system is the moving the part are absent, so the maintenance are required. The contact breaker point are absent, so no arcing. The spark plug life increased by the 50% and they can be used about the 60,000 kilometers without any problem. The more power output, more fuel efficiency, better combustion in the combustion chamber, about 90 to 95% of the air fuel mixture is a burn compared with the 70 to 75% with the conventional. Now, type of the electronic ignition system. The capacitive discharging ignition system, transistorized the system, piezoelectric ignition system, Texagon ignition system. So in this ignition system we can show that it is a similar that we can show the earlier, but the main change is the electronic control unit. As we can see the earlier, when the switch is the ignition switch is on, and the battery will supply the current and will be to the dual plus resistor and the primary and the secondary winding. Now this primary winding is now with the connected with the ECU primary winding and the distributor and the distributor. Now when this primary winding is stop their winding, stop their current, at that time the secondary winding will generate the high voltage, and this high voltage is goes to the distributor cap and the rotor, and finally as we said earlier it is goes to the spark plug, and the spark will be the spark generated in the spark plug. The summary: all the inductive ignition systems supply battery voltage to the positive side of the ignition coil and the pulse, and the negative side of the coil on and the off to the ground to create the high voltage spark. If an ignition system uses a distributor, it is a distributed ignition system. If the ignition system does not use a distributor, it is called the electronic ignition system. The waste spark ignition system fire two spark plugs at the same time. A coil on the plug ignition system uses an ignition coil for each spark plug. Now there is a quiz section is there. So I put the 10 questions of this quiz, and I having the 4 options for that. Just give me the answer in this below notes, and I will reply for that shortly. Thank you for watching this my video. Have a nice day.